Indian scientists refuting an Australian team's claim to have detected the light from the first stars to whether eating more insects could help save our planet. These are some of the stories that we talk about on this episode of Scientifics. I am Mohana Basu, and every week on ThePrint Scientifics, I take you through some of the top science stories of the week from across the globe. This week, a team of researchers with the Raman Research Institute in India has refuted the results of an experiment conducted 4 years ago where a team in Australia claimed to have found evidence of the cosmic dawn. Their research, published in the prestigious journal Nature Astronomy, outlines how they tried to replicate the Australian team's experiment and why they believe their failure to achieve the same results casts doubt on the efforts of the former team. In 2018, a team of radio astronomers in Australia used an instrument they called the experiment to detect the global epoch of reionization signature to find evidence of cosmic dawn, that is, light from the oldest stars in the universe. Their device was meant to detect changes in interstellar hydrogen due to ultraviolet light emitted from the first stars. Such changes would involve hydrogen changing from a transparent state to slightly opaque. When their device recorded seeing the changes they were looking for, the team claimed that they had found the first evidence of the cosmic dawn. However, in 4 years, no other team has been able to replicate these results. The team in Bengaluru tried again by placing a device called the Shaped Antenna Measurement of Background Radio Spectrum, or SARAS, on the surface of water bodies in India. The team deployed SARAS on 2 water bodies, the Dandi Ganghali Lake and Sharavati backwaters. These were chosen specifically as the reservoir had to be one with just the right salinity to shield the device from underground background radiation. After finding the right reservoir, the researchers set up their device and set about looking for the evidence of the cosmic dawn, but they found none. The group claims that their failure shows that the results by the team in Australia were faulty. They suggest the earlier findings were likely due to faulty equipment. But this study does not end the debate on whether or not the team from Australia saw signs of the cosmic dawn. Several other teams are still in the process of setting their own experiments to see if they can find the cosmic dawn. Also this week, a pair of researchers at Liverpool John Moores University, who used a new method of studying dinosaur tracks, found that sauropods walked with a gait that was unlike anything seen in any creature alive today. Previous research has shown that elephants walk by taking 2 steps on one side, then 2 steps on the other. Paleontologists have so far assumed that big dinosaurs also walked with a similar gait because of their large size. However, researchers found that not to be the case. In this new study, the team suggests that because of the massive size of sauropods, walking like an elephant would have required a lot of energy just to keep them from toppling over to one side. They created a method to study dinosaur trackways that involves accounting for variations in tracks and timing as an animal moves forward. Analyzing trackways for 3 sauropods found that a front foot touched down on the ground just before the hind foot of the opposite side was lifted. This gait suggests that the giant creatures didn't wobble as they walk, thereby preserving energy. Meanwhile, researchers from Curtin University have devised a new metric which determines the age distribution fingerprint of minerals known as zircon within sand, which can help reveal insights into the evolution of the Earth's surface over the last few billion years. Most of the original geological record is lost over billions of years of erosion, making it difficult for scientists to recreate the history of the Earth's surface. Minerals like zircon are durable and form sediments that effectively gather information from these lost times to paint a picture of the planet's history, including changing environments, the development of a habitable biosphere, the evolution of continents, and the accumulation of mineral resources at ancient plate boundaries. According to the team, this paves the way for a greater understanding of the nature of ancient geology in order to reconstruct the arrangement and movement of tectonic plates on Earth through time. Zircons contain chemical elements that allow scientists to date and reconstruct the conditions of mineral formation. The new technique allows them to chart the evolution of continents by identifying the particular age distribution fingerprint of zircon grains in a sample. Also this week, scientists have found that a system that in 2020 was reported to be the closest black hole to Earth actually has no black hole in it. A team led by European Southern Observatory astronomers had reported a system designated HR 6819 to be the closest black hole to Earth, located just 1,000 light years away. However, a team from Belgium found that there is in fact no black hole in the system. Instead, they report this is a vampire two-star system in a rare and short-lived stage of its evolution. The original study received significant attention from both the press and scientists. The team that had led the original research said that they welcomed the scrutiny of their research. The team from ESO were convinced that the best explanation for the data they had obtained with the 2.2-meter telescope was that the system was a triple system with one star orbiting a black hole every 40 days and a second star with a much wider orbit. But the new study now proposes a different explanation for the same data. This system could only be of two stars with a 40-day orbit and no black hole. This alternative scenario would require one of the stars to be stripped, meaning that they at an earlier time had lost a fraction of its mass to another star. The two research groups will now collaborate to monitor HR 6819 more closely and conduct a joint study of the system over time to better understand its evolution, constrain its properties, and use that knowledge to learn more about other binary systems. Insects, which are a part of cuisine in many cultures, are an excellent source of protein for humans. But now, researchers suggest that the insect waste can also help promote sustainable crops. The team argues that adding insects to our diet could enhance plant growth, health, pollination, and resilience. The leftovers from insect production come in two main forms. The first is exuviae, which are exoskeletons. The second is frass, named for the German word for eating. Frass is basically insect poop and unconsumed food. When added to soil, the exuviae and frass promote both plant growth and health. Insect feces are rich in nitrogen, a nutrient that is important to plant growth but is scarce in most soil. Therefore, it is often added to the soil as a synthetic fertilizer. The insect exoskeletons are rich in chitin, a polymer that is difficult for most organisms to digest. The team sees the application of insect rearing byproducts to crops as a novel step towards a circular food system in which there is very little waste. The insects are fed waste streams from crop farming or food production, and the insects then provide humans with food. Using the leftovers from insect production to bolster crop growth could close this circle. This is Mohana Basu, special correspondent at ThePrint. If you like our work, do consider paying for a subscription to ThePrint. You can do so through the link in the description box below.